A plastic bucket, a kilogram of common potatoes, a handful of soil taken from under the trees of a forest, a tablespoon of coarse salt, and 5 minutes of your time. That is all you need to set up a living biological factory in your backyard. A factory that multiplies on its own every 48 hours. It produces 6 different plant hormones simultaneously and outperforms products found on the shelves of gardening stores, which cost $150, $200, or sometimes $250 per liter. The agricultural chemical industry calls these compounds growth regulators. Scientists call them phytohormones, and the Korean farmers who discovered how to manufacture all of this inside a bucket 60 years ago called them indigenous microorganisms. By the end of this video, you will know the exact recipe. You will understand the biology behind how this works, and you will understand why a billion-dollar industry would prefer you never learn the name of the Korean man who gave this technology to the entire world for free. But before any of these things make sense, you need to understand one thing. You need to understand what is actually happening inside that bucket. Because what we are talking about here is not fertilizer. What we are talking about is a living colony of microscopic organisms that copy themselves. Organisms that produce, on their own, the same hormones that companies manufacture inside expensive industrial laboratories. These are the same hormones that decide if a seed will germinate, if a stem will stretch, if a root will branch out, or if a fruit will swell. All of this is produced by bacteria, all of this is produced for free, and all of this doubles in quantity every 48 hours inside a plastic bucket in your garage, without electricity, without a motor, without anything. If you have ever stood in front of the shelf of an agricultural store, looking at bottles labeled with complicated names, words like microbial inoculant, beneficial fungi mix, soil probiotic, or biostimulant complex, and wondered if it all really works, you are about to learn something that changes the entire calculation. Because the substance inside those bottles is not a modern invention, it is not a discovery of cutting-edge agricultural biotechnology. The microbes you are paying dearly for were already alive on the forest floor, 100 meters from where you grew up. They live in the earth under every healthy tree on the planet. And for thousands of years, traditional agricultural cultures across several continents discovered how to collect these microbes, how to multiply them, and how to feed their crops with them, using nothing but rainwater, a source of starch, and patience. Chemical companies figured out how to freeze and dry these same microbes, pack them in a jar, and charge you $300 for a teaspoon of what you could grow yourself at home in unlimited quantities. And that is exactly why this story is so important. Because the history of agriculture made with microbes is not just a story about bacteria. It is a story about how traditional agricultural knowledge is erased. It is a story about how simple biological processes become paid products, and about how a billion-dollar industry is built on the backs of organisms that any farmer could grow in a bucket for the price of a potato. This story begins in 1965. In an agricultural village in South Korea, a young farmer named Cho Han-kyu had been observing his neighbors destroying their own land. The Korea of the 1960s was in the middle of a green revolution. Synthetic fertilizers were being pushed onto farmers as the future of agriculture. In the first few years, production rose. Then the soil began to fail. Crops became dependent on increasingly larger doses of chemicals. Soil organisms disappeared, plants weakened, and diseases increased. Cho Han-kyu refused to participate. He turned his attention to something he had observed as a child. Under the layer of fallen leaves in any Korean forest, the soil was alive, loose dark, full of white fungi and microscopic life. No one had ever thrown fertilizer on that ground. And yet the trees grew there for centuries without any intervention, only rain, sun, fallen leaves, and microbes. Cho Han-kyu spent 30 years asking a devastating question. If the forest fertilizes itself for free, why couldn't a garden do the same thing? What he discovered became known as Korean natural farming. The central insight was simple. Healthy soil is not a substrate of minerals. It is a living ecosystem. If you collect the microorganisms from a forest floor, multiply them, and introduce them into the garden soil, you regenerate the same fertility that built the forest. I'll tell you something. When I first heard about this, I thought it was talk. I thought it was just another one of those alternative methods people spread on the internet without any backing. But then I went to read, I went to look for research, and what I found left me open-mouthed. In the 90s, Cho Han-kyu's son, Cho Jong-sung, took his father's work and created a simpler, faster, easier-to-scale version. He called it Jadam, a Korean word that translates roughly as people who look like nature. And the main product of this system is a microbial solution that, where the father's process took 5 steps spread over weeks, could be cultivated in a single bucket in 2 or 3 days. And he gave this away for free. He never patented it. He published the recipe in books and on a free website used today by more than 100,000 farmers in Korea, Africa, Asia, and the Americas. Now here is what makes this story truly extraordinary. While Cho Han-kyu was observing the Korean forest soil and discovering how to bottle that biology, a completely independent line of scientific research was happening 10,000 kilometers away inside a laboratory in the United States. In 1970, American researchers isolated compounds from corn pollen and applied them to bean seedlings. The stems elongated rapidly, cell division accelerated, and the plants grew in a way that the hormones known at the time could not explain. They processed more than 200 kilos of pollen just to extract 4 millimoles of pure compound. And when they crystallized the substance, they discovered something impressive. It was a real steroid molecule. Plants had their own steroid hormones. They always had, and no one had noticed in 200 years of research. If you are enjoying this deep dive, tell me in the comments which city and state you are watching this video from, and subscribe to the channel so you don't miss any of the next ones. We always bring these stories that no one else tells. And here is where the two stories collide. The microorganisms that Cho Han-kyu collected from the floor of the Korean forests are not generic decomposers. Scientific research has documented exactly what they do. They produce hormones. Bacteria that dominate forest soil produce plant hormones as part of their normal metabolism. The hormone that controls roots, those that control cell division and shoots, those that control stem elongation and germination, and enzymes that protect against stress. And some of these bacteria also produce compounds similar to plant steroids, the same family that Americans took 40 years to identify. The microbes were producing this on every forest floor on the planet for hundreds of millions of years before any scientist gave a name to a molecule. Let me explain what this means in practice. Think of an industrial reactor, one of those steel tanks full of sensors that biotechnology companies use to manufacture medicines. Now take that concept and shrink it down to a plastic bucket in your garage. That is what you are setting up. Potato as fuel, salt as mineral, forest soil as the seed of life, and water as the medium. In the first 24 hours, the bacteria begin to multiply explosively. In 48 hours, the population has already doubled several times. By around 72 hours, the fermentation bacteria dominate. The starch turns into sugar. The sugar feeds the microbes. The microbes produce acids that dissolve minerals. And throughout this entire cascade, these bacteria manufacture plant hormones hundreds of times faster than they would if they were just sitting in the soil. When you pour this liquid into the garden, you are not just adding water. You are adding a complete hormonal cocktail with living microbes that colonize your soil and continue producing hormones in there for weeks. No commercial product delivers all of this at the same time in a living form. And the reason is not scientific, it is structural. A living culture does not survive on a shelf. The same chemistry that makes the solution so powerful makes it impossible to package and sell. Now here is the question the industry hopes you don't ask. If native microorganisms can be grown at home, if the preparation that comes from this is proven to produce the same hormones that products sell, if the entire process costs less than $2 per bucket and produces enough material to fertilize an entire garden, why is the global biofertilizer market worth more than $3 billion? The answer boils down to 3 things. First, standardization. A commercial product delivers a specific strain in an exact concentration. A homemade bucket contains a mixed population that changes according to the forest soil, the temperature, and the season. Industrial farms do not operate with variation, but your home garden can and benefits from diversity. In ecology, diversity is resilience. Second, the appearance of complexity. The biofertilizer packaging looks like advanced chemistry. Scientific names, percentages, certification seals. A bucket of fermenting potato water looks like peasant stuff. It looks rural, it looks backward, but the science under the bucket is identical. The same microbes, the same hormones. What changes is the packaging and the profit margin. Third, the language barrier. The Jadam website is in Korean. The technique spread through Asia and Latin America decades before being translated into English. While English speakers were paying 50 for this biology in an imported jar, we here were already growing our own fertilizer in a bucket for 2 generations. It was never hidden. It was on the other side of a language barrier that, for you, no longer exists. And now, after all this context, here is the recipe. The 5-minute setup that starts a colony of microbes that doubles every 48 hours inside a bucket. Pay attention because the details really matter. You will need a plastic bucket of about 20 liters, a common bucket. Do not use metal. Metal interferes with microbial activity and can rust in the slightly acidic environment of fermentation. You will need about 15 liters of clean water without chlorine. This is fundamental. Tap water with chlorine kills the bacteria before they even establish themselves. If you only have chlorinated water, leave it in an open container in the sun for 24 hours. This makes the chlorine evaporate. Rainwater is the best of all. While water works, filtered water works, you will need half a kilogram of common potatoes, about 2 or 3 medium potatoes. Wash them, but do not peel them. Cut them into pieces and boil them in about 2 liters of water for 20 to 30 minutes until they are soft enough to mash easily with a fork. The potato starch is the fuel the microbes will use to multiply. The cooking water becomes a starch-rich broth that you pour into the bucket along with the potato. You will need about 2 tablespoons of coarse salt or unrefined sea salt. It is not fine table salt. It is not salt with iodine. It is coarse salt or rock salt, the kind that still has its natural minerals. Salt provides minerals, regulates the pressure inside the microbe's cells, and favors the growth of the good ones over the bad ones at this concentration. And you will need 1 to 2 cups of forest soil. This is the critical inoculant. It is the heart of everything. Go into the nearest native forest you can find. Push away the layer of fallen leaves from the top and dig 5 to 10 centimeters down into that dark, soft earth, full of white fungi. That earth contains the entire microbial community that you are about to multiply. If you cannot find forest soil, use the richest and oldest compost you have or worm castings from an established compost bin. The assembly is the 5-minute part. Take a pair of clean socks, the high-top kind, or a piece of fabric like voile. Put the cooked potatoes inside a sock or a cloth bundle and tie it. Put the forest soil inside another. Hang the 2 bundles inside the bucket so they are submerged in the 15 liters of chlorine-free water. Throw in the coarse salt, stir everything, and place the bucket somewhere in the shade. The ideal temperature is between 15 and 29 degrees Celsius. Cover loosely with a lid or a cloth to keep insects away and reduce evaporation, but do not seal it hermetically. The fermentation will produce gas. And that's it. 5 minutes of actual work. Now biology takes control. In the first 12 hours, the bacteria population already begins to multiply. In 24 hours, you will see a foam forming on the surface. By around 48 hours, the foam will be thick, dense, full of bubbles, sometimes visibly bubbling. This foam is the sign that the colony has hit the first major explosion phase. By around 72 hours, the preparation is fully active and ready to use. In warmer weather, it may be ready in 48 hours. In colder weather, it may take 4 days. The visible sign is the foam. When you see that thick layer, almost looking like yeast on top of the water, your solution is alive. To use it, dilute the solution in a ratio of 1 part solution to 10 parts water and apply by soaking the soil around the base of the plants. Apply once every 2 or 3 weeks during the growing season for maintenance, or once a week during the active growth phase if you are trying to regenerate exhausted soil. And here is the most beautiful part of all. A single ready bucket can also be used to start an unlimited number of new buckets. You take half a cup of the ready solution and add it to a new bucket with water, potato, and salt. You skip the forest soil step completely after the first bucket. The microbial colony now perpetuates itself. This is the double forever feature. As long as you keep feeding the colony, it keeps multiplying. A single bag of potatoes can produce an entire season's worth of biological fertilizer from a single original collection of forest soil. I have to be honest with you about the limitations, because credibility matters more than excitement. The solution is not magic. It does not replace compost, organic matter, mulch, or mineral correction in very exhausted soils. Microbes need carbon. Soil without organic matter does not sustain them. The preparation is temperature sensitive. Below 15 degrees, fermentation slows down. In freezing temperatures, the culture dies. The storage time is 2 to 3 weeks before the preparation spoils. You make it, you use it, you make more. There is no shelf life because there is no shelf. Always dilute in a 1:10 ratio before applying. Never use salt with iodine. Never pour the pure solution directly on the plants. And with new seedlings, start with a lower concentration and observe before increasing. Cho Han-kyu died in 2021. He spent 6 decades teaching farmers in more than 30 countries to manufacture their own inputs. He never patented anything. He published everything. His son continues the work through a nonprofit educational network. The recipes are free, the videos are free, and they have already been translated. The most powerful soil conditioner on the planet is not locked behind a patent. It is reproducing right now, at this moment, on every healthy forest floor on the planet. It can be collected with a shovel, multiplied in a bucket, and applied for free. The science is complete. The biology is resolved. The barrier between you and a thriving garden is a trip to the forest, a bag of potatoes, and 5 minutes with a bucket. The forest floor knows. Cho Han-kyu knew. Now you know too. If this story changed the way you look at the soil beneath your feet, please subscribe and like the video. We are unearthing the biological history that they tried to bury. Let's plant the future together. The next treasure from the earth will be opened very soon.